I'd like to introduce Donag Moorhead from the Carbon Trust, who will be presenting today.
Good morning, everybody. Thank you, Susan. So we'll start off just looking at the quick agenda. We'll be looking at the various forms of data that you can use, where you can obtain them. I think the idea today is to just go through some of the straightforward analysis and interpreting techniques that you can use. We're not going to get into anything too complicated. So we'll look at the likes of regression analysis, which is useful with regards to consumption, and the QSUM analysis, as well as degree day analysis for those that are looking at the likes of building energy use and consumption. So our aim is hopefully to show you how to use the data that you have to help to develop a kind of your own site energy consumption model, so that you should have a good idea of what you should be consuming and compare that against what you are. Using the techniques then to help you to identify where saving opportunities are. We'll take a quick look at some key performance indicators which are useful for cross comparison, whether that be process lines or indeed in whatever sector you're in. That'll also give you an indication as to how efficient a process you're running, and that at the end will outline how you can obtain some further support from the Carbon Trust. That's the old monitoring and targeting adage. I'm sure many of you have come across it before, but Lord Kelvin, if you can't measure it, you cannot improve it. So this is why we're trying to drive the use of the information that you can readily have available at your fingertips, and the opportunities that can produce in terms of energy improvement. Okay, quick one about the Carbon Trust. Sure you all know, not-for-profit organisation. Our mission is to accelerate the move to a sustainable low carbon economy. We do that in 3 ways: by offering advice to governments and the businesses as to the opportunities that is available. We also measure and help certify environmental footprints for organisations, for products and for services. And we also help and develop low carbon technologies and solutions. So quickly on, why bother with the data? I'm sure all of you, or some of you, will have had a monitoring and target system, or been exposed to one where it's been gathering information for weeks, months, years, and nothing really is done with it. The reason you would want to analyze your consumption data, in particular your half-hourly or quarter-hourly, is the insight that will give you into how and where energy has been used at the site. It helps you understand then what are the main energy drivers at the site, what causes you to use more energy or less energy. Again, you can then run a comparison, whether internally or externally, using your key performance indicators that help, I suppose, in essence, place you in the kind of energy management hierarchy. Obviously, then with use of the data, you're looking to identify opportunities, but also at the same time helping you to quantify what that opportunity looks like. And at the end of the day, it's all about helping you reduce your bottom line costs. Okay, so just a quick one on the data granularity. Obviously, the more granularity that you have in the data, the better your analysis is going to be. So for the likes of a weekly meter reading, I mean, we would consider that reasonably coarse. It's not the worst, obviously. If you're only going to be measuring them once a month, then the kind of insight that that's going to give you is very slight. In terms of your half hourly data, now that can come from a variety of sources that we'll talk about, but that's kind of the energy management de facto standard. That's kind of what everybody would be looking to achieve. So it's also important not to try and take the granularity too far. I mean, you're not wanting a reading every 30 seconds or anything like that. You just end up with far too much information, and it's hard to analyze, and it can be just overwhelming. So I think half hourly data at this stage is plenty for everybody. In terms of where you can get that kind of granularity of information, well, obviously your utility provider, as long as you have a half hourly meter, they can provide that for you. You can typically ask for it on a monthly basis, and it comes as a little Excel file that you can then analyze. Gas is slightly different. Unless you have your own submeter on the gas, and typically you are going to get that monthly readings. So that's one that you can easily improve on yourself by starting to take your own readings. If you do have submeters, then great. They can be often manually read, typically weekly. If it is, try and improve that again. If it's automated, then that'll be in half hourly readings as well. Some additional information to look out for. Obviously, if you're beginning to understand what the drivers are at the site, then you want to be taking a note of that. As typically, if it's manufacturer, then it's going to be the level of production. So that can be whatever it needs to be that in square meters or liters of product or ton of product. And if it's kind of building energy that you want to analyze, then the most obvious source of information there is degree days, which are now freely available online. So in terms of then what to look at when you have the data, and the whole premise of the data analysis is it's fundamentally a gap analysis, or a review of your actual energy consumption and that which you expect or has been predicted, and we'll touch on that later. It's an exercise in trying to understand what it is you are looking at and what it should look like, and that's just down to curiosity. It's just asking the question, is that how I would expect it? And if it's not, then you need to dig a little further, look a little harder. So some of the very basic kind of analysis would be just this one's for electricity consumption over the day of the week. So as you can see, you know that it's going to be they've got 4 12-hour shifts, the Monday to Thursday. That looks about right. Then you can see where the consumption's dropping when they aren't producing anything. Again, you're trying to compare that with what they would be if they were producing. So there's still quite a high energy consumption from the Friday to Sunday when ostensibly nothing is being produced, and that's equating to 24% of the site energy consumption. So you begin to build a picture there of what's actually going on when nothing's being made. So you're trying to quantify what's going to make up that 24% consumption when the site is shut down. Again, just a different different site type. You've got the site operating 2 shifts just through Monday to Friday. Consumption over the weekdays is as flat as it comes. Again, you're still looking at the weekend consumption just to further iterate that out of hours consumption and trying to understand what's going on at the site that's causing that continuous consumption. Again, that's just a typical office consumption as well, where you've got it's fairly flat over the standard office hours, but still the weekend drops down to half the weekday consumption, with the baseline over the weekend equating to about 16% of the site overall consumption. So still something going on. Now there's obviously going to be some load. There'd be security lighting or IT server rooms, etc. But still, as a percentage of the overall weekly consumption, it's quite high. That's where the likes of the out of hours auditing or out of hours walk around can work very, very well for the office environment, just so that you can see what is being left on. So going from the weekly kind of daily totals, then you've highlighted some of the days where the consumption has gone out of range or over the weekend. So the next thing you would look to do is see what the daily profiles look like. Obviously, you must spread them across the days of the week, but there's a very obvious pattern going on. So that's the 4 12-hour shifts. You can see the early shutdown on the Friday is as expected. And then the out of hours base load then is well quantified at over 100 kilowatts, which, I mean, okay, for a manufacturing site, that's still high. Could be heavy refrigeration, and so there is going to be a constant, but over 100 still warrants a bit of investigation. And similarly there, and just standard office hours, very similar analysis, just highlighting the out of hours consumption. Interesting that orange line, the Saturday line, where it begins to ramp up at the normal opening hours. So there's something been left on the BMS there that seems to be ramping up. It could be the water pipe or the water pumps or something like that coming on. And there's the curious peak on the Friday. I think that's probably New Year's Day, that Friday line. But it does pay you to try and work out why the profile is like that. Are things beginning to ramp up at the right time? Is there issues with BMS settings? All of those can be, or all those kind of thoughts can be triggered by just looking at the profile charts. This is one that you can use to check your maximum demand. You can see there it's coming out at about 1600. So you're going to be charged for what your maximum demand level is. If you're not coming anywhere near that, then you can have that reduced. And there's a good saving to be had from that. You need to be sure that that you're not going to need that demand in the future, because if you have to go back and ask for it, then they will charge you to increase it again. You'd typically use a chart like that to analyze the option for combined heat and power at a site. There you can see there's a constant load there for 300 kilowatts throughout the year. Of course, it would depend what the site heat load was as to whether or not the CHP would be viable, but useful to look at. So trying to understand why your profiles are, how they are, what the variability is, and what causes that variability. And they're fairly obvious in terms of manufacturing sites, etc. That's it's broadly always going to come down to the level of production, or so you would think. We'll go on and look at what the relationships are actually like with that in the next few slides. From a building point of view, you're into the actual site conditions. So degree days are the biggest driver there. So if we go on then and look at some analysis of the energy consumption against a few of the energy drivers, then to see how we can interpret that data. There's the electricity consumption, or the blue bars, and the site production level is the red line. So what you would be expecting that to do is that those two track well with one another. Broadly speaking, it does. But you can see there in August, when the production levels are fairly constant from June or July, August to September, that the production has dropped down. So you would have expected the electricity consumption to drop accordingly. Similar in May. The site in question had a heavy reliance on refrigeration, so the May, regardless of where the production was, it may have been that they were particularly hot months, and the refrigeration equipment was having to work a lot harder than that. But you can do a closer analysis of that relationship looking at regression analysis. So that's a fairly standard function on Excel, where you're plotting a scatter graph of the energy used and the production of tons. That gives you then the equation of the line, which is the y is equal to mx plus c, where and that's able to tell you quite a bit, where you have the base load of the site is the 106,190, so that's what the site's going to consume regardless of whether it's manufacturing anything or not, and it gives you a unit of electricity consumption for every unit of production. So in effect, it gives you an equation that will predict the site energy consumption based on a level of production. The R squared value then is always the number between 0 and 1. The higher the number, the better. It's an indication that for that particular one, 30% of the variation in the electrical consumption can be explained by production, which is low, because then that's meaning that the remainder of it is obviously down to things that aren't being attributed directly to production, and therefore inefficient. We talked about the importance of the granularity of the data. The previous one was obviously monthly, which is I think too coarse to get any kind of meaningful information from regression analysis. So there's one that's looking at weekly tons manufactured goods against the related energy consumption. Again, it's giving you the equation of the line is your that's the model that you use to predict how well your energy consumption is relating to the level of production. I'll note the 2 points highlighted there, just to bring out some of the detail. You've got a very similar level of manufacture, and yet you've got quite a disparity in terms of how much energy that has used. So it's again, it's asking you or it's causing you to ask questions about why that should be different. What's going on that has caused that disparity. Now, you're able to use that equation then, where you have X is going to be your level of production. You drop that in the equation, and your Y value is going to be your predicted energy consumption. So where that begins to vary from the baseline, which is the output of the model, then it's really easy to graphically represent that, where if you're using more than what the model predicts, then obviously you're going to want to highlight that and investigate it. But similarly, where you're using less than has been predicted, then it's as equally important to investigate the causes of that and see if there are any learnings that can be taken forward. So then some little bit of more detailed analysis, then further use of the regression analysis and your equation of the line is to do some QSUM analysis on it. Again, you've got the column there, which is your expected energy consumption, which you get by dropping the number of the production units into the equation for your X, and then your Y will then be your expected. You plot that against your actual, and then that will throw out the difference between obviously the expected and the actual. And over time, then you're able to build a reasonable picture of what the variations are. In terms of the graphic analysis, the significant points are where you have a significant change in the slope of the graph, which is indicating that something has happened there to cause either an increase or a decrease in the energy consumption. Obviously, the more that it rises, that's showing that the efficiency of the system is declining, and then where it is dropping, then that's what you want to see, is the energy efficiency is improving. But it's looking for the points to change that indicate that something has gone awry, and again, it's using that information to highlight these and then to try and understand what that means in terms of its cause. Okay, for building energy then, the more detailed analysis beyond just plotting the daily consumption across the week or the daily profiles is to utilize what the main energy driver is going to be in terms of consumption. Obviously, it's whether or not the office is open or not, but just in terms of being able to relate the typically the gas consumption to the degree days. Obviously, if it's an all electric office, then you can use the degree days to analyze how closely they track as well. You can also get cooling days as well. Again, if it's heavily reliant on air conditioning, then that can be a useful analysis as well. But for the sake of today, we're going to look at the use of degree days for the gas consumption. Okay, so similar to when we were plotting the level of production against the energy consumption, you would expect the level of the gas consumption to track well with the number of degree days. The degree days are going to signify when heating should be required at the site and at what level. So again, that you're looking at the January, February, when the heating demand or the gas used was essentially the same, and yet you've got the degree days have dropped off. So you would have expected the February consumption to drop as well. Again, these are all just indicators as to there being a problem. Again, just a regression analysis similar to the previous, and again, have to put the caveat on it that it's only 12 months worth of data, but the correlation is reasonable, so you'd be reasonably happy to use the data. Again, just highlighting the obvious anomalies were for similar degree days on the right, or yeah, for similar degree days on the right-hand graphic there, there's a significant change in how much gas was used, and similarly for very similar gas consumption, the actual heat requirement that the model predicts is also significantly different as well. So quickly then, for use of performance indicators, the idea is to identify what the key energy driver is at the site. So we've discussed that it could be just production levels, could be the amount of refrigeration that you're using, and the volume that you're having to put through that. It could be degree days. In terms of the production values, it's important to remember that you need to include the waste at the production level. Often the level of production excludes the any kind of waste, but at the end of the day, if the waste has gone through the process, then there is an energy penalty as a result. And so to get kind of accurate numbers out the other side, then you need to include that as well. Your key performance indicator then, so that could be your kilowatts per meter squared, it could be whatever the production level is, that allows you then to benchmark across the site. Now that can be if you've got a number of production lines, so you begin to look at what the key performance indicator is for each line. If it's significantly different, then you need to understand why that is. Is that in terms of how the particular shifts are setting up the equipment? Maybe it's how the staff are running it. All of these are very useful learnings to understand. I mean, if one shift is able to produce the product more efficiently, well, then there are learnings there that should be and could be cascaded down to the other shifts, so that that can be understood as well. The KPIs also allow you to benchmark yourself against others in your industry or sector, and there would be good examples of that for the likes of the dairy sector and the plastics sector as well. But there's a wide range of information on that's freely available, and which you can use to, I suppose, almost position yourself as to how efficient your process is against another, and therefore that'll highlight that there are more opportunities there to be gained. So we'd talked about the importance of the data granularity, just in terms of the insights that can give you. Talked about the half-hourly data being fairly standard, but it's not the only information that you can use. The analysis of the information, as we've shown, it doesn't have to be complex to be useful. It's more about you trying to understand what the information is actually telling you, and trying to find reasons as to why there should have been that variation from your expectation or from the energy consumption model or the regression analysis. Obviously, that kind of the whole aim of the analysis is to help you to identify those areas that warrant further investigation. And it's important to spend a little bit of time having a think about what would be the most meaningful energy driver at the site. It may not be just as easy as the tons of product that is produced. You may have different product lines or which you're gonna have to take into consideration as well. And we've looked at then trying to get a handle on what a good key performance indicator would be for the site or the building, and how to use that to effectively benchmark yourself against good practice in your sector. So go on and go through some of the Carbon Trust support that's available through the Green Business Fund. This is a scheme that we've been operating across England, Scotland, and Wales now for 3 years. It's coming to the end of the programme now, but there's still quite a bit of help and assistance available. At the minute, it's a combination of offering advice and training. So it's, as I said, England, Scotland, Wales, open to a wide variety of sectors. There are some obvious exclusions, as you would expect, and it's open to SMEs across the area. At the minute, we're got some upcoming workshops. These usually take a couple of hours, hosted by Carbon Trust partners in the area. That's delivered by the Carbon Trust, and got some simple goals at them, is to help organisations understand their energy consumption, to identify some easy, low or no cost measures, and where, as I said, it's open to SMEs. And there's three events coming up now in June as well. So if you're close to any of the locations, that I would advise you to get yourself along. They're well worth it for 2-hour investment of your time. So we've got some other support. This is the opportunity assessment. So these can be remote advice or on-site advice. Obviously, it depends on your level of energy consumption. They're delivered by Carbon Trust engineers such as myself, and we'll get you identify the top 3 costed energy saving recommendations, and they're available for SMEs in obviously the qualifying geographies: England, Scotland, Wales. There's also implementation advice. So if we've or if you have your own projects, or if you're wanting to implement the recommendations that we have provided, then there is support available from us, where we'll help to put together the tender, run the tender, identify suppliers from our Green Business Directory who will be more than capable of implementing the projects as well. So it's not just limited to any of the recommendations that we may have made. If you've got a project in mind for yourselves, and you just need some support or some hand-holding in implementing that, then the implementation advice would be for you. We've talked about the technical webinars. You're in the middle, or you're coming to the end of one of them now. And we've also got a vast array of excellent publications that we have on a whole variety of technologies and subjects. So they're freely available through the website. We've also just released a couple of online tools as well, which you can access. One to help you measure your organization's carbon footprint. And as we'd discussed then, the other option is to benchmark your energy use as well, and that'll be using your identified KPI. And you can also, because of the success in the rollout of LED lighting as well, we offer some support if you need to put a business case together. So if your organization is still operating either fluorescent or metal halide lighting, then you need to change them out, because it's a very cost-effective project. Now you're looking at a payback, depending on the existing lighting, of between 3 and 3.5 years. So we're more than happy to assist you with that as well. Susan, any questions?
Yes, so we've had a few questions come through, so I'm not sure if we'll have time to do them all, but we'll try and pick out a few. So the first question is, what is the process for being able to use half-hourly data to find the electrical load duration in respect of finding the maximum demand?
It should actually, you don't need to use the actual half-hourly data to do that. That should be readily identified on your bill. It will tell you what your maximum demand had been during that billing period, and your bill should also indicate as to what maximum demand you're being charged for. So the easiest way would be to check the bill. Again, if you're going to query it, just make sure that you've had a look over a variety of years, just to check that you are well within your maximum demand limit. But yeah, the easiest way to do it is to look at the bills.
Okay, next question. Can you use degree days for an office which is heated by electric heaters, but the electricity consumption data is for the entire electricity consumption of the office? For example, you cannot split the heating consumption data from the entire consumption data.
Yes, it can be used. I mean, because the biggest impact throughout the year that's going to cause the change is once you start using the heating. Essentially all the rest of the consumption, you can look at that as a baseline, as normal consumption, if you will. So yes, the increase in the electricity consumption due to the heating will should actually track very well with the degree days. Again, it's important to understand that it will be slightly different if it's air conditioning that's been used to heat it, because obviously then there's going to be, if that's used during the summer as well, then that's going to skew it slightly. But if it's purely used for heating, then yeah, you can use the degree day. I've done that myself, so easily done.
Okay, someone asks, I'm not sure if you've covered this or not, where can degree day data be obtained?
It's very freely available. If you type it into one of the search engines, there's one or two that are based in the UK, and it's freely available for all locations. So
Okay, just a couple more.
sure.
Next one is, I've been trying to compare energy usage for several buildings of different sizes. They are primarily offices. One of the ways I've considered to make the data comparable is energy consumed by me. Is this a good method?
Energy consumed by
It just says me,
me. Not
or, well, it says M3, but I thought that was a typo, but maybe not.
Oh, no, it isn't. No,
Sorry.
no, that's fine. Doing it by volume, usually you would do it by square meter, but I guess you could do it by volume. I don't know that you'll come up with you would get very many kind of sector benchmarks that would do it by meters cubed. So I'd try it. Standard practice would be square meters, and you'll be able to find plenty of industry benchmarks that you can use to help compare that. The likes of the CIBSE data has plenty of information on office types and what the expected kilowatt hour per meter squared would be. So I would start with that.
Okay. If a company has a half-hourly meter, is the energy company legally required to provide that data on request? Some suppliers appear to charge extra for the data.
Yeah, I don't. They can be a bit sneaky about that, to be honest. That's at the end of the day, it's your information, and at the end of the day, you're going to change suppliers at some stage. So I would, if it was me, I would be playing hardball with them, and I would be demanding it. Also, when you go out to change supplier, then it would be useful to get it written into the contract that they will supply you with that information.
Okay, and we'll just take the final one. Do you have experience of using cooling degree days, and what base temperature is best to use?
Yeah. Yes, the cooling degree days, you'll get them at the same websites that you'll get the heating degree days. The base temperature, I mean, that's going to depend on the office office orientation, office type. I guess it's a very similar process to choosing the base temperature of the heating degree days. I mean, the standard would be 15.5 degrees, but it depends on the building. It depends on the results as well. If they just don't look right, then you go through a process of iteration, really, until you're reasonably happy with what the model looks like. So it's not a very prescribed process. I guess it also depends on what your settings are for your air conditioning. I mean, if you're operating a deadband, then the base temperature could go way up. I mean, if you're only heating till 18 degrees and you're only going to cool to 23, then that's which would be considered best practice. If that's what you're at, then yeah, you're gonna need to adjust that base temperature up.
Okay, great. Well, I think that's all the questions we have.
Okay, Susan, thank you very much.
Thanks very much. Thanks everyone for attending. Have a great day.
Okay, cheers now. Bye-bye.